Hello student, today we are going to discuss stoichiometric related problem. Last class we completed mole concept, especially how to calculate the number of moles in terms of a number, in terms of a mass, in terms of a volume. And with these applications, then we need to calculate different types of things based on the stoichiometry of a reactions. Stoichiometry is nothing but a Greek word, is nothing but a measuring. Whenever this stoichiometric related problem will be there, in this stoichiometric related problem, there will be percentage impurity problem, there will be percentage composition problem, there will be limiting reagent problems. All those things will come one by one. And whenever there is a stoichiometric related problem will be there, first you have to write down the balanced chemical equation. That means in a chemistry, if you mix A with B is forming C. Then you have to write down the balanced equation, means how many moles of A will react fully with how many moles of B and forming how many moles of C. That is called stoichiometry. So now, like that small mole reaction, I hope already you know in a 10th standard. Here also you will come to know a few more, and then you have to remember that reactions. That means, like if I say calcium carbonate, limestone, everybody knows in 10th standard also. Calcium carbonate heating will give you what? Calcium oxide as well as carbon dioxide. You have to write down for balanced reaction. Like a nitrogen react with a hydrogen is forming ammonia. For that, you have to write down the balanced equations. Like how to do the balance, we know by trial and error method. By trial and error method, we can write down the balanced chemical equation. Whenever this stoichiometric related problem will be there, like percentage composition problem, percentage purity problem, or percentage impurity problem, percentage yield problem. So then first job is to always remember you have to write down the balanced chemical equation and we have to proceed with that. Let us look at that stoichiometric related problem. Stoichiometric related problem. In that stoichiometric related problems, first topics we will discuss nothing but a percentage purity problem. First we will discuss percentage purity problems. And we know how to calculate the number of moles and all those things in terms of a mass. All those things will give you help over here itself. Percentage purity problem. In percentage purity problem, first what I will give you that problem, because stoichiometry related nothing but a special type of problem handling. It's a tools how you will handle the different level of problems. So now first, if I am giving you first small example, suppose I am giving you 100 gram of calcium carbonate on heating giving 25 gram of calcium oxide. So what they are giving over here, 100 gram of calcium carbonate on heating giving 25 gram of calcium oxide. And then they are asking percentage purity of calcium carbonate is how much? That was the questions. Now, if you look at, first I told you whatever like that percentage purity, percentage composition, percentage yield, like that problem they will ask, all are stoichiometric related problem. First you need to write down the balanced chemical equation. Yes or no? So let us write down the balanced chemical equation. Calcium carbonate on heating, what are the product will give. So then everybody knows calcium carbonate is a limestone, very famous in 10th standard. On heating, this sign, delta sign in chemistry means heating. On calcium carbonate on heating is producing calcium oxide plus carbon dioxide. You look at automatically this is a balanced reaction. Both the side, I hope you know 10th standard how to write down the balanced chemical equation by trial and error method. Now generally in left hand side of the equation is a reactant side, right hand side of the equation is a product side, general convention. So now that here if you look at over here in calcium carbonate 1 calcium, right side also in the form of a calcium oxide there is a calcium that is also 1. Total carbon is 1, right side also total carbon is 1. Total oxygen atom is 3, right side with carbon dioxide 2 and with calcium oxide 1. Total oxygen is 3. So everything is balanced. Now next job is to once you write down the balanced, then by default you will get the mole ratio as well as you will get the mass ratio. That means how many moles of reactant, how many moles of product used to give. Reaction always will occur as per stoichiometry. So that means that's why I told whenever stoichiometric related problem will be there, your first job is to write down the balanced chemical equation, compulsory. Then only we will come to know how many moles of reactant is giving how many moles of product. And by default, I will get to know how much amount of the reactant is giving how much amount of the product. Because yesterday we discussed mole to the amount of substance. How can I reach? Multiplied by molar mass. So likewise, if we know that 1 mole of calcium carbonate is giving 1 mole of calcium oxide and 1 mole of carbon dioxide, then multiplied with a molar mass of calcium carbonate, we will get the amount of calcium carbonate in the stoichiometry of the equation. So then here 1 mole was there. With 1 mole, molar mass of calcium carbonate is 100, calcium is 40. Molar mass of calcium carbonate, if you calculate, calcium is 40, carbon is 12, each oxygen atom 16, 3 into 16, which is nothing but it gives rise to 100. Yes or no? So that is nothing but a gram, 100 gram molar mass calcium carbonate. That means 100 gram of calcium carbonate when is dissociating, always you look at calcium 40 and oxygen 16. Then calcium oxide is how much? 56 gram. Then carbon is 12, each oxygen is 16, 2 into 16, 32 plus 12, how much? 44 gram. So that means 100 gram of calcium carbonate on dissociation will give 56 gram of calcium oxide as per stoichiometry if it is 100% pure. Then I will take a reverse. If you look at 56 gram of calcium oxide originally used to come from 100 gram of calcium carbonate. But here you look at 100 gram is giving only 25 gram. That means some percentage of impure substance is there in 100 gram of calcium carbonate. We need to catch that it up. And then that amount I need to convert in a percentage. Then I will get the percentage of impurity. I can do it in terms of a percentage of impurity. And then 100 minus percentage of impurity is a percentage of purity. Because always remember percentage of purity plus percentage of impurity will be equals to 100. Suppose if you look at simple logic, suppose if you have a total apple 20, out of that Ram has a 4 apple and then Sam has a rest of the apple, then percentage how we used to do? 4 by 20 into 100. Sam has a rest of the apple, that means 20 minus 4, 16. 16 by 20 into 100, that is a percentage. Yes or no? So now same way, that means both the percentage if you add, that means Ram percentage plus some percentage apple if you add, that will give you to what? 100. Same way, percentage of purity plus percentage of impurity will be equals to 100. Because total always in terms of a percentage, total summed up always will be 100. And in terms of a fraction, total fraction if you add, always it will be 1. So then fraction means out of 1, percentage means out of 100. Fraction into 100, fraction into 100 you will get percentage. percentage divided by 100 you will get in terms of a fractions. Is it clear or not? So now this is the idea. Percentage of purity plus percentage of impurity equals to 100. Now you look at, if the calcium carbonate is 100% pure, then that 100 gram of calcium carbonate used to produce 56 gram of calcium oxide. That means 56 gram of calcium oxide used to come from 100 gram of pure 100 gram of calcium carbonate, provided if it is 100% pure. So that only I am writing. Then 56 gram of calcium carbonate coming from 100 gram of calcium carbonate. Then 1 gram will come from how much? 100 by 56 gram of calcium carbonate. Then if you look at 25 gram will come from how much? 100 by 56 into 25. So then we have to do my calculations. If you look at these things to 50 and these things to 28, these things to 14, these things to 25. Then 25 into 25 divided by 14. So then here if you look at 25 into 25 we have to do na 125 here. Here you will get 2 into 25 50. So then 5. So then 2. So then 625. So 625 by 14. We are getting 625 by 14. So then if you calculate these things, so immediately here also you will get like this. 14 4s are 14 5s are 70, 14 4s are 56. Okay na? So then 14 4s are 56 and here 65 again, 44 and 56, and then immediately you will get over here 9, then 0.0, then 90 means you know very well, 14 5 ja 70, 14 6 ja 84, and 14 7 ja 98. So then 14.6 ja. So 44.6 gram is requirement is there. So that means your 25 gram of calcium oxide is coming from 44.6 gram. That means out of 100 gram pure calcium carbonate which is reacted, which is nothing but a 44.6. So then immediately percentage purity means if you look at percentage purity means amount really reacted by amount giving into 100. So then percentage purity means how much reacted. You look at amount really reacted, this much gram, because this much gram is only capable to give your 25 gram of calcium carbonate. Yes or no? Because you look at 56 gram used to come from 100 gram. Then I calculate 25 gram of calcium oxide is coming from how much gram of calcium carbonate, which is nothing but a 44.6 gram is capable to give 25 gram of calcium oxide. So that means out of 100 gram only pure substance was there 44.6 and rest is impure. So that's why percentage purity, percentage means what? Whatever pure, that means whatever really reacted with respect to that whatever total is there into 100. That's why percentage purity means amount really reacted by amount given into 100, that is a percentage purity. What is percentage purity? Percentage purity is nothing but a amount really reacted by amount giving into 100. So then if you look at over here, then we calculated amount really reacted how much? 44.6. Then your percentage purity will be equals to, for this problem, percentage purity will be equals to amount really reacted. Amount really reacted is nothing but how much? 44.6. amount giving means how much total giving? 100 into 100. So then immediately you will get, you look at, this is your calculation, 100 cancel, then you are getting 44.6 is your answer. Yes or no? Clear or not? So that is the idea. Always whenever the percentage purity problem is giving, you need to find out of that given amount, how much amount, or how out of the given mole, how much mole is really reacted. So then the amount really reacted by amount giving into 100 is your percentage purity. Yes or no? Clear or not? This is percentage purity. So let us try another problem in terms of a percentage purity. Let us try with another one or two problem. Yes or no? Okay, let's go with another problem. So here next problem, what they are giving? They are giving like that, 10 gram of MnO2 on reaction with HCl given 2.24 liter of Cl2 gas at STP or NTP. That day we discussed what is STP, NTP. Standard temperature pressure, normal temperature pressure. Both cases temperature is 273 Kelvin. Only NTP pressure is 1 atmosphere, STP pressure is 1 bar. And atmosphere and bar are not equal, is almost like if you say 1 atmosphere will be equals to 1.023 bar, or 1 bar will be equals to 0.98 atmosphere, like that. So that's why at STP and NTP. Another is their SATP condition. That point to be noted. What is, everybody knows? Do you know these things? What is SATP? Standard ambient temperature pressure. Here temperature should be 298 K. Pressure should be 1 atmosphere. And this is called as a standard ambient temperature pressure. So generally room atmosphere. Room atmosphere means room temperature nearby 25, and temperature is 25 means 20 centigrade. Centigrade to Kelvin conversion means plus 273 we have to do. So that's why 298 Kelvin. Then you will get to Kelvin. Centigrade to Kelvin means centigrade plus 273 equals to Kelvin. And then pressure is 1 atmosphere. Atmospheric pressure is 1. So that is called as a SATP conditions. So now here the problem they are giving, 10 gram of MnO2, one reaction with HCl given 2.2 liter of Cl2 gas at STP or NTP by following equations. What equation they are giving? They are giving like this: MnO2 react with 4HCl is giving MnCl2 plus Cl2 plus 2H2. This is the equation. And now you look at everything balance. 1 manganese, 2 oxygen atom, 4 hydrogen atom, 4 hydrogen atom, 4 chlorine atom, 4 chlorine atom. This is a balanced reaction. By default they are given to you. But small reaction you need to know. थोड़ा बहुत तो खुद को भी जानना पड़ेगा ना यार. So that's why small equations you need to remember. Okay na? So that's why you need to understood. थोड़ा small equation जो रहता है book में, especially NCERT book, so you have to remember that one, and slowly it will comes to you, need not to worry. But here they are giving, that is not our botherations. So now you look at, here they are giving 10 gram of MnO2 reaction with HCl giving 2.24 liter of Cl2 gas at STP or NTP by following equations. These are they are given. Now what is the questions they are asking? Then they are asking percentage of impurity in MnO2? That is the question. Don't make mistake. You are thinking, sir, teach me, sir, percentage purity equals to amount really reacted by amount given into 100. So that answer you should not report, but they are asking not percentage purity, my dear. They are asking percentage of impurity. Percentage purity, whatever you will calculate, 100 minus percentage of purity if you did, then only you will get percentage of impurity. Why? Because I told percentage of purity plus percentage of impurity is nothing but a what? 100. That's why 100 minus percentage of purity is nothing but a percentage of impurity. As simple as that. There is no hard and fast or tough rule. Very easy. So now if you look at over here, then first for that purpose what they are giving, how much amount of chlorine gas is giving. From there I need to catch out of 10 gram really how much MnO2 is reacted. Then I can find out the percentage purity of MnO2. Let us start to solve this problem. Okay na? So now if you look at this many liter of chlorine gas NTP, then I can find out number of moles of Cl2, already you know sign, will be equals to given volume by 22.4 liter. What is the given volume? The volume which is mentioned in the problem, this is the given volume. So given volume is, that is the formula, given volume by 22.4 liter at STP or NTP. This is a given volume in liter. This is nothing but your given volume. Yes or no? This is nothing but your given volume. कुछ तो बोला करो यार. So given volume this one. So then number of moles will be equals to given volume by 22.4 liters. So then given volume here how much giving? 2.24 divided by 22.4. So this is, and this one decimal point if you cancelled here you will get 100. Decimal point here if you cancelled you will put here 10. This is cancelling, this 0, this is 1 by 10. 1 by 10 means 0.1 mole. Yes or no? Now you look at 0.1 mole of chlorine is coming. Then you look at the stoichiometry. 1 mole of MnO2 used to give 1 mole of chlorine. Reaction always will happen as per stoichiometry. That's why I told always in stoichiometric related problem you need to write down the balanced chemical equation. Why? You will get the, by default you will get the mole ratio, which mole ratio reactant is reacting and which mole ratio product is forming. And once you write down that balanced chemical equation, once you will get the moles idea, by default you will get the mass idea. That means here 1 mole means the molar mass amount of MnO2 is reacted. Molar mass of MnO2 means mass of all the element of substance, multiply their atomicity, add up, you will get the molar mass. Yes or no? So then immediately here you look at molar mass of MnO2. Molar mass of MnO2 will be equals to manganese is 55.5, oxygen 2 into 16, 32, which is nothing but a gives rise to 87.5 gram. This is the molar mass of MnO2. And now if you look at 1 mole of chlorine used to come from 1 mole of MnO2. Now we got how much chlorine is coming? 0.1 mole. So then 0.1 mole of chlorine definitely will come from 0.1 mole of MnO2. Reaction will happen as per stoichiometry, always as per balanced equations. So that means 0.1 mole of MnO2 means how much amount of MnO2? Because 1 mole of MnO2 is, 1 mole of MnO2 equals to 87.5 gram. Then 0.1 mole of MnO2, that means 1 by 10 MnO2, which is nothing but a 8.75 gram. Yes or no? That means 8.75 gram is enough to produce 0.1 mole of chlorine. But here is there how much? 10 gram of MnO2. That means 10 minus 8.75, that amount is nothing but a impure substance present in MnO2. So then that means, or we can say out of 10 gram, really reacted is how much? 8.75 gram. So then my percentage purity will be equals to amount really reacted, which is nothing but a 8.75 an amount giving how much? 10 into 100 is your percentage of purity. So then immediately you write down here these things, 100 cancelled, then you are getting 87.5%. This is your percentage of purity. So then in this problem they are not asking the percentage of purity, they are asking percentage of impurity. Then we know percentage of purity plus percentage of impurity equals to 100. So then immediately I can write down percentage of impurity will be equals to 100 minus percentage of purity. Percentage of purity already we calculated, which is 87.5. So that's why 100 minus 87.5, which is nothing but a 12.5%. Yes or no? Clear or not? Understood or not? So that is the idea. Everybody understood this problem? I hope no problem in it. Very simple. First we calculate percentage of purity. How we calculate? For that purpose they giving data of chlorine. From the chlorine mole we catch how much mole of MnO2 really reacted. From mole converted to the amount multiplying by molar mass, we came to know 8.75 gram is really reacted out of 10 gram. Then percentage purity we calculate 8.75, which is really reacted with respect to the amount giving, which is 10 into 100. We got percentage purity 87.5. Then percentage of impurity is nothing but a 100 minus percentage of purity is nothing but a percentage of impurity. We got it, which is 12.5. Is it clear or not? Okay. So thank you all. Next class we will discuss limiting reagent problem. Thank you very much.